See, in last class, before that linear constant coefficient differential equation, this was the equation, and we took Ey common and we denoted that as gamma square. Just what I do, this I'll send that side, this will become positive, this will become negative. Is it or not? This will be a negative. Now this negative sign can be represented as j square.
Yes, sir.
Then what I do, what are the common I can take? Ey common, j common because this minus is j square, then omega, then what is one more? Mu. This is common because mu is here as well as here. Then what is left out? Sigma.
Plus.
That's all. Sigma plus j. This one j is left out. J omega. Sorry. J epsilon. Is it right?
Yes.
This plus j omega epsilon. J. Is it fine? Then no, I'll call this as gamma square. Gamma square is equal to Ey. That is dou square Ey by dou x square. Where gamma square is? What is your gamma square?
Sigma plus j.
J omega mu. This is, and gamma is propagation constant. And it is a complex. By saying this, is it complex or not?
Yes.
And this can be written as alpha plus j beta, where this is attenuation constant and this is phase shift constant. We will define when we derive expression for this gamma. This expression plays an important role for deriving the expression for attenuation constant and phase constant. Definitely I will use this expression. Is it clear? Any doubt you have? No? Is it fine? Then further we will proceed with this equation. Further we will proceed with this equation. Call it as equation number some R. Equation R gives. After this, have you taken that or not? You need to say what is gamma, what is alpha, what is beta. But we will define what is alpha, what is beta later. Equation R gives linear, constant, coefficient, differential equation. LCCD. Okay. Equation R gives linear, constant, coefficient, differential equation. And its solution R1. Shall I write this? I am saying solution R. First solution I will write. And second solution. See, first solution, it is a function of which variable?
X.
X. Just I will write Ey x. First solution, just I will write this as a e to the power, what is constant?
Gamma.
Gamma minus gamma x propagating x direction plus b e to the power plus gamma x. One is e to the power minus gamma x, one is e to the power. This you studied in your differential calculus. And one more solution, second solution. See, this equation is function of one in space or distance x. But what I said, electromagnetic wave is a function of space as well as time. It is a function of space as well as time. Yes or no? Then what shall I write this? The one more solution is E y x comma t. I wrote function of distance or space as well as time. It is equal to real value of so and so. What is that so and so? This thing. Multiplied by this whole thing multiplied by e to the power j omega. See, it is a function of space as well as time. How to get the function of space as well as time? Just this is a function of distance. You take as it is multiplied by e to the power j omega t and take its real value. Definitely, the solution may be in terms of exponential, cos, or sine. Yes or no? These are the things. No, when we do like this, it will be a function of cos or maybe sine. We'll see. Is it okay? Nothing new. You studied this in your differential calculus. Then, shall I write this? No, I want to proceed with this solution, not with this solution. Because this is a function of
Time and space.
space and time. Shall I proceed with this?
Yes, sir.
Then it is equal to real value of a e to the power minus gamma x. What is your gamma? From that expression?
J.
Alpha plus j beta x multiplied by e to the power j omega. Then this plus e to the power, it is plus gamma is there. Here it was minus, minus I wrote plus. What is your gamma? Alpha plus j beta into x. Gamma x is just alpha plus j beta into x e to the power j omega t.
You
Is it
forgot
fine?
writing B, sir. B. Plus B. Yes.
Fine. Is it okay? Any doubt you have? Just to obtain function of distance as well as time, what I did for this?
Multiply.
Multiplied by e to the power j omega t and took a real. Then this can be written as real value of a e to the power this minus gamma x e to the power minus j beta x e to the power j omega t. Can I write like this?
Yes, sir.
E to the power minus gamma x, then e to the power minus j beta x, then e to the power j omega t plus b e to the power gamma x, b e to the power gamma x, e to the power j beta x, e to the power j omega t. Fine? No, it is equal to real value of, see, j and j is common here. Here also j and j is common. Shall I write that as a e to the power minus alpha x e to the power j omega t minus beta x? Can I write like that? J I took common, omega t minus beta x. That is, just see this, real value of a e to the power gamma x. I wrote this as it is. Then j I will take common, omega t minus beta x. J I took common, omega t minus beta x plus b e to the power alpha x, then e to the power j I will take common, omega t plus beta x. Fine? Then, no, you tell me, I want to take what is, this is an amplitude. Real value of amplitude will remain same. No, this is an exponential, it will be having e to the power j theta as cos theta plus j sin theta. The real value of this remains same. How you will express e to the power j theta? Cos theta plus j sin theta. Then cos theta plus j sin theta means which is the real value and which is the imaginary?
Cos theta.
Then no, I'll take, see the real value of this is, I'll write it as e to the power y x comma t equal to, what is the real value of first term? A e to the power cos omega t minus b plus b e to the power gamma x cos omega t plus beta x. Is it fine? Any doubt? See, it is having the wave propagating in, see this will indicate the wave propagating in the x direction. It will be having component, electric field component in the y direction. Even this will indicate wave propagating in x direction, or this will indicate wave propagating in x direction. No, out of these two components, which is forward traveling wave and which is backward traveling wave?
A is forward and B
This
is
is forward traveling wave and this is
backward traveling wave.
Because this is minus, this is plus.
Yeah.
We found EY. Then which is the one more component we need to find?
H.
HZ. No, whether you want to do same thing by taking that wave equation in terms of H, or from this you want to apply.
From this.
From this, using one simple relation. Have you taken up to this?
Yes.
Call it as equation number. Yes. Equation yes. Take on. Equation yes gives. Equation yes gives electric field component. Electric field component EY x comma t, this thing. In bracket, in which direction electric field component?
Y.
Y direction. Y direction. Field component is in Y direction. In bracket you write the Y direction. For a wave propagating in
X direction.
X direction. Wave is propagating in X direction. Electric field component in Y direction. The first component of our equation is
Forward.
forward traveling wave. And second component is backward traveling wave. Then what is this A e to the power gamma x? What is this thing? Amplitude of forward traveling wave, and it decays with the distance. Yes or no? As you are going away, the amplitude, I'll draw the figure for this also. Please, I need this equation. I'll draw. It will decay as you go. Then what about B into e to the power? It is amplitude of backward traveling wave. Is it or not? If you are coming from here to, let us take x is equal to 0 something. If you are coming, then what about it will increase or decrease? It is e to the power gamma x. Whether you are traveling away or whether you are traveling towards, it depends whether increase or decrease. This is just, I'll write amplitude of backward traveling wave. Fine? We'll analyze this also shortly. But more we analyze forward traveling wave. This backward traveling wave exists only for conductor. For any other medium, backward traveling wave won't exist. Even when reflection वगैरह comes during that time also, will enhance this concept. Okay, then now I'll define one more parameter called intrinsic impedance. We derive relation for this. It is denoted by eta. After this, we will derive relation for this also. We will derive equation for this. Intrinsic impedance of a medium, in general, it is a lossy medium. or in general, take on intrinsic impedance of a medium for a wave propagating in x direction, for a medium in which, better, for a medium in which wave is propagating in x direction is defined as ratio of, see the wave is propagating in x direction means ratio of Ey divided by Hz. Are you getting it? E by H it is. The wave propagating in x direction means E will be existing in which direction? Y. H will be in Z. Now if I take, let us take, the wave is propagating in Y direction. The wave is propagating in Y direction. Then, what about this? In which direction it will exist? What is AE?
AZ cross AX.
AZ?
Cross AX. AX. AX no sir.
Is it right?
Yes sir.
Fine?
Cyclic on
AZ, AX. Fine. It's right. Right now? No. Intrinsic impedance of a medium in which wave propagating in y direction is defined as
E
divided by Hx. Ez divided by Hx. Now I'll take one more possibility. Ax into Ay. Intrinsic impedance of a medium in which wave is propagating in z direction is defined as Ex by
Hy.
H. Is it clear this way?
Yes.
Again, it is E by H, no doubt. But Y or X or Z depends upon the wave propagation and its component. Is it clear?
Yes sir.
No, already I found this. This is complex in nature. This is complex in nature. It will be having magnitude as well as phase. Intrinsic impedance is complex in nature. It is having magnitude as well as phase. Already I derived what is Ey. From this expression, can I get Hz? Hz is E divided by
Right.
intrinsic impedance. Yes or no? Is it okay? Call it as equation number P. From equation P, shall I write this?
Yes.
From equation P, what is your Hz? From equation P,
Ey x comma t by eta.
Ey x comma
T
t by mu. Eta. It is having magnitude as well as
Phase.
in polar form. I will write this. Theta. Yes or no?
Yes sir.
Then this will be written as, just concentrate. One marks question के लिए be ready. Be ready for one marks question. I will write this as a e to the power minus gamma x cos omega t minus beta x plus that equation b e to the power cos omega t plus beta x divided by okay. Then shall I write this?
Yes.
Or else this you can write this in the form of e to the power j theta n also, not an issue. This is in polar form, you can write e to the power j theta. No, I will write this as, just see this, a e to the power cos by magnitude of this cos omega t minus beta x minus theta n. Even here itself, I will write a minus. I will tell you. I'll ask you why minus. Wait, here itself I will write a minus because this is just one hint is it is backward traveling wave. I will tell you. And minus same minus I will write b e to the power gamma x cos omega t plus beta x minus theta n divided by magnitude of n. Now tell me, one is phase is introduced here. Phase is introduced. And one more thing, it has become negative. Two questions who will answer. For each one, 1 marks. आपका final interval marks. Anyone? First y minus. I'll come to this. First y minus. Y minus. Anyone? This is minus y.
Because it's backward direction.
Backward then? Either minus नहीं आया फिर?
The forward.
It is forward. This is backward. See, just concentrate. A K A E A H. See, this is forward traveling wave. First component is forward traveling wave. Is it or not? This is your HZ. It should be HZ because AX, AY,
Result.
AZ. This has to be positive for forward traveling wave and this should be a positive. No, backward traveling wave के लिए concentrate AX. See, already AE I found. In which direction it is?
Y.
AY. Then I don't want to change that. This should be
Minus AZ.
minus A. And I will tell you this. You open any textbook. This concept is nowhere clear because they are not gone for backward traveling. Because it will become a complex.
Yeah.
It will become minus. No, even you open a study code textbook, they are not treated backward traveling. Only forward traveling they are. In some textbook they might have done, but why this negative sign? No way. Is it clear why this negative sign? Clear to all?
Yes, sir.
Yes or no? Please let me know. This is one. Then coming to y theta. This is simple, not that complicated. Just see. I will divide this by e to the power j theta n. This whole thing I will divide by e to the power
J.
j theta n. When it goes to numerator, what happens?
E to the power minus.
E to the power minus j theta n. I want to take real value of that.
Yeah.
Then cos of. Here one more e to the power minus j theta n. Theta n will be introduced. Then
So
this minus theta n will be introduced or not
Yes,
in terms
sir.
of cos.
Yes.
Is it clear? Second one is simple, but first one is
Complex.
not complicated thinking. Is it okay?
Yes, sir.
But the amplitude is divided by this amplitude is divided by amplitude of intrinsic impedance. This amplitude is divided by amplitude of intrinsic impedance. This is your H Z x comma. These two equations you call this as equation number yes. Now what is this equation?
H.
Chalo, I'll call it as A. Fine. I'll start with the A. See, equation yes and A will give two components. One is electric field component, magnetic field component of a wave traveling in which direction?
X
X
direction.
direction. Take down further. No, I'll further. Equation yes and A. We need to analyze dot from here. Equation yes and A. Equation yes and A will give electric field and magnetic field component. They are component, not complete field. Is it or not?
Yes.
Because EY and SZ. Electric field and magnetic field component of electromagnetic wave. propagating in x direction. No. What is the difference between, have taken propagating in x direction? What is the difference between S and A, equation S and A? By seeing equation S and A, what you can say? The magnitude is decreasing, no doubt. Magnitude is decreasing by an amount, constant amount. That is a constant. What is the major difference between this equation and that?
Phase.
Phase. What is the change in phase?
Theta.
This is lagging by
Theta.
intrinsic impedance. Phase angle of intrinsic impedance. Or, in other words, this is
Ahead.
leading.
Yes.
You can say, if you write, either you write this is lagging by phase angle of intrinsic impedance, or this is leading by
Phase
phase
and
in objective. In objective. In lossy dielectric. Magnetic field components dash lags are, leads are, equal are, same are electric field component. Means lags by an angle which is equal to
intrinsic.
intrinsic impedance of phase angle of intrinsic impedance. Just take on by seeing equation A and S. Very important this. By seeing equation A and S, we can say magnetic field component lags, is it or not? Lags the
Electric field.
electric field component by
Intrinsic impedance.
by what? Phase angle of intrinsic impedance. By phase angle of intrinsic impedance. In other sentence, you want to note on this? Or this leads electric field component leads magnetic field component by phase angle of intrinsic impedance. What will you say? Yes or no? No. I have drawn, means we got an equation for electric field as well as magnetic field. No, I will draw one figure. Only I can draw electric field here. Shall I write this?
Yes, sir.
Sure. Let us draw electromagnetic wave for this. The wave is propagating in the x direction. What about E?
Y direction.
Only at present I will draw forward traveling wave. It is something like this. Just please don't talk. This is your e to the power gamma x. The magnitude is decaying exponentially.
Yes, sir.
That's why what I even just earlier for uniform plane wave the magnitude were constant. But here the magnitude is decaying exponentially. This is your E. You want me to draw H also for this? You want me to draw H also? H is perpendicular to the bird
Yeah.
and exponentially decaying.
Yeah.
And it is lagging in phase by theta. Yes or no? Difficult to draw?
A bit.
For example, let us take this much angle is theta n.
It starts from there.
Yes or no? Means this H will be
Starting
from here it will start.
yes.
Are you getting? From here it will start H and it is perpendicular to O. Just possibly मुझे पता नहीं how I can draw this मगर कैसा draw कर सकता हूँ ये ऐसा just this will be like this enter into the bird leave the bird enter into the bird but what about the amplitude
Decreases.
decreasing exponential but from here it will start if it is starting from 0 H will start from here just Just let me. But difficult. Are you getting? Can you imagine or not? This is your H. But H is lagging by an angle theta. And our E is lagging by an angle theta. Sorry, E is leading by an angle theta. And our H is lagging by an angle theta. Again, I saw figure this expression in any textbook it is missing. You won't get this expression in any textbook. That is damn sure. Is it clear?
Yes, sir.
No. This is, but for another three medium, we'll draw the figure clearly. Because in free space and lossless dielectric, attenuation won't be there. Attenuation won't be there means the amplitude remains
Same, sir.
constant. But with mathematics we see. I said attenuation won't be 0 means alpha should be, what should be your alpha? 0.
0.
Alpha 0 means attenuation remains constant.
Constant.
That all we will see with the mathematics. This is the field components of electromagnetic wave traveling in lossy dielectric. Then after that, shall we see the expression for propagation constant, that is gamma?
Yes, sir.
Then after that alpha and beta, then expression for, even we derive expression for intrinsic impedance also, that is eta. I define, but we will derive. See, what are the things I need to do is expression for this alpha and beta, then intrinsic impedance. Then if I know all these things, velocity of propagation, I'll do it, lambda we do it, is it or not? Okay, let us complete all these things for lossy dielectric. Then let us use the result of this for remaining three medium. One more class I will take to derive the expression for this, then another half an hour to one hour for analyzing remaining three mediums. Then that completes the theory of this unit. Then we will deal with the problems. For problems, full theory we need to know. Then let us take the expression for, shall I run this? Have you taken this figure? Take down. Expression for propagation constant or expression for attenuation constant and phase shift constant. Don't talk. What was gamma square? Just I have put J omega
Mu of sigma plus J epsilon
J omega epsilon.
epsilon.
Is it fine?
Yes.
If you do a mistake here, then we will wind up with a wrong result. Then what is your gamma?
Root over
And this gamma is equal to alpha plus J. No, what is your alpha? Attenuation constant. Let us define this attenuation constant here. What this attenuation constant indicates?
real part.
See, e to the power minus gamma x I wrote. This is forward. Then this is indicating spatial rate of decay of electromagnetic wave. It is indicating decay, is it or not?
Yes.
Yes, define. Attenuation constant, it is defined as spatial rate of decay of electromagnetic wave in a medium, while traveling in a medium. Spatial or spatial, what you call? This spatial rate of decay of electromagnetic wave in a medium, while propagating in a medium. Then, what is the unit of this? Decibels per meter or meters per meter? Then what about beta?
Phase constant.
Phase shift constant. How you are going to define this phase shift constant? No, definition. Phase shift per unit length.
Okay, yes sir.
Phase shift of the electromagnetic wave per unit length or per length. Phase shift of electromagnetic wave per length. What is the unit of this?
Degree per meter.
Radians per meter. Phase shift will be in terms of radian electron. 2 pi by lambda. Beta is equal to 2 pi by lambda, something like that. Radians per meter. Okay. Done. Is it clear? What is attenuation constant? Spatial rate of decay of electromagnetic wave while traveling in a medium. What is phase shift constant? Phase shift per length. Okay? Then, shall I write this? Shh, please don't talk. Then, call it as equation number 8. Squaring both sides of equation A. Square both sides of equation A. What do you get? Alpha plus j beta whole square is equal to j omega mu plus j omega beta. Yes or no?
Yes.
That square root will go. When I take a square, then this is equal to alpha. We expand this alpha square plus j beta square
minus beta square
beta square
plus 2
j
alpha
alpha beta is equal to this will be written as j omega mu this minus j into j minus j square is minus 1 omega square. No, you equate real and imaginary part.
That's what.
Equate real and imaginary part. Alpha square minus beta square equal to what? Minus omega square mu epsilon. And what about 2 alpha beta? Omega mu. Call it as equation number 3 and D. Okay?
Yes.
Shall I write this? Okay. No. Shh. See. No, whether I want to derive an expression for alpha or beta. It's left to you.
Alpha.
Alpha. Then substitute the value of beta from this. Okay. Then, but remaining you need to do. For beta you need to do. Otherwise I will do one you need to do. I will write an expression for that. See, you want to derive an expression for alpha. Then what is beta from C? Alpha square. Beta in terms of alpha I will write. Minus
Omega square mu square sigma square by 4 alpha square.
Can I write?
Yes sir.
This is equation C. I'll write equation C like this. From equation D equal to minus. Yes, sir. Then I'll write this as alpha square. I'll write this as 4.
Sir, 2 alpha whole square.
Wait.
Akkada beta is divided by 2 alpha whole square.
2 alpha. This is 2 alpha.
Sir, remove the square, sir. By the whole square you put now.
It is 2 alpha, just 2 alpha. Right? No, what I do, this 2 alpha I will take common. This is omega square, mu square, this, by 4 alpha square. Can I write this as 4 alpha to the power
4
equal to alpha square omega square. Is it right? Can I do like this or not?
Yes.
See, if you do a mistake, you won't get a result. Is it fine? Done. I'll write this as 4 alpha square to the power square like this. In terms of x square.
Okay.
Then this will come this side plus 4 alpha square. X square x. Just I'll write this as 4 omega square mu epsilon. This is your a x square plus b x omega square mu square. See, this is in the form of ax plus bx plus c.
Ax square.
Is it all right?
Yes.
What is the solution for this?
Minus
Is equal to
minus b
b plus or minus b square minus 2ac divided by 2a. Now tell me what is a here? A equal to 4, b equal to 4 omega square mu epsilon, c equal to minus. Alright? Then what is your x? What is your x?
alpha square.
Then do that. Shall I write this?
Yes.
Then alpha square equal to minus p.
Square minus
What is minus p? Minus 4 omega square mu. See, plus or minus is there. I'll take the plus only for both cases because alpha and the attenuation constant and phase shift constant, they won't be a negative. That's why I'll take it as plus root of p square. What is b? 16 omega to the power 4 mu square epsilon square b square minus 4 a. What is a? Into 4. What is c?
Minus omega square
Minus will become plus omega square.
mu square
Can you see this point? C what is?
mu square
Omega square mu square.
sigma square.
Is it okay? Then whole thing divided by
8.
2
into 4.
Then I'll write this as minus 4 omega square plus
Plus or minus 1. Sir, 16 if you take out it's 4, sir. So 4 root over.
I will tell you this. Plus see 4 this is divided by 8. This is divided by 8 plus root see what I want to do here is I want to take just see this will be omega square mu epsilon. Is it possible to take omega square mu epsilon out?
No, sir. Only omega you can take out.
Just see this. I'll write that 16. If I take omega to the power 4 outside,
Omega square.
omega square. This omega square I'm getting.
But
Wait. Omega to the power 4 I'll write. If I take mu square out,
mu.
Yes, this mu I'll get. Mu square. If I take epsilon square out, epsilon. This much I'll take common. I'll write it as 1.
By okay.
I'll write it as 1 plus then what I took common? 4 into 4, 16.
Yes.
That is fine. Then omega to the power 4 I took common.